in this one, we're going to talk about when the straight line will be parallel to each other or perpendicular to each other. So in first one, we talk about the parallel case. So I will just tell you the results, or like what the stuff are. So record is y equal to mx plus c, and I will usually put m is not equal to 0. Then you got here, for example, I will just tell you the result first. So if m1 equal to m2, then the two line will be parallel, or you say L1 is parallel to L2. So for example, if L1 is y equal to x and L2 is y equal to x plus 1, you can try to draw the graph. The first one is just look like this, which here would be 45 angle degree. The angle will be 45 degree. Okay, and the second one, and this one will pass 0, 0, and the 1, 1. If you try to put a few point on it, and this one, of course, will go through 0, 1, which was the y-intercept. So we'll pass here, and the other one will be 2. I will put 1. I'll put 1. It will be easier to see, and the other one will be 1, 2, which will be here. Then you draw the graph. It will look like this, and remember to put everything you better put everything on it. So y equal to x plus 1, y equal to x, and yes, that's the graph of two functions, real life function, and you can probably see they are parallel, and you can try more cases if you want. The point here is just trying to find a different number for c in different functions of straight lines. And the second one I was going to talk about was the perpendicular case. So if two lines are perpendicular, then m1 times m2 will be equal to -1, and you can get L1, which is line 1, will be perpendicular to L2. And again, you can try to think of an example of it. It's really hard to prove, actually, not for the high school student, I think. Actually, you can prove it, but you need to use a lot of stuff. So I'm too lazy to go through all of them. So I will just put an example here. So again, you can try to think about y equal to, for example, x, and y equal to -x. Then this one will be L1, L2. This one might be the most obvious one to see why they are perpendicular. So if you can recall, y equal to x, it will just pass the origin, whatever, the 0, 0, and the angle will be 45 degree. And the other one, y equal to -x, this one will just be 45 degree here, or you can say 135 in this really big angle. And again, you can put y equal x, y equal to -x, -x, and why this is 45 degree, I'm going to show you the magic of it. So recall y equal to x, it can pass through 0, 0 and 1, 1, and if it's 1, 1, which means this line, the length of this will be 1, and the length of this will be 1, and this will be a right angle, because you put a like perpendicular line here. So when this is equal to this, then you got a triangle where the angle is just 45 degree and 45 degree here. Okay, it's simple math, it's primary school math, probably year 7, year 8, whatever. And the other one is the same, y equal to -x. And again, it passes 0, 0 as always, and -1, 1. Though it's -1, but the length is the absolute value of it. So it is, the length of this will still be 1, and the length of this will still be 1 as well. And this is the right angle. So again, these lines are equal. Then you got 45 degree, 45 degrees. And if this is 45 degree, this one will just be supplementary angle, and it will go 180 minus 45, which is 135 degree. Okay, it looks pretty awesome, and woohoo!